أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الصلاة والسلام على سيدنا محمد وعلى آله وأصحابه أجمعين. Welcome to today's talk. My name is Harun Reşit Acaroğlu. I am a theoretical particle physicist. I hold a PhD degree in theoretical particle physics. I also hold a second PhD degree in Islamic theology, and in this second PhD program I have studied Islamic prayer times from a theological point of view, but also from historical and most importantly astronomical perspectives. And today I want to basically summarize the most important results of my PhD studies in this hopefully 90 minutes talk. My dissertation, my PhD thesis, has been published in the Vakar Yayınları publishing house, or the Vakar publishing house, and it can be purchased on the webpage of Vakar Yayınları. And it, aside from the academic title, it also bears the title, the Arabic title, Inaratul Afaqi wal Afhami fi Ilmi al-Miqat, which can be translated as the Enlightening of Horizons and Minds in the Science of Timekeeping. There is something special about this title, which is that, if you sum up or add up the letters of this title according to the abjad system, which is the Arabic alphanumeric system, then you end up with 1446, which is the Hijri year in which the thesis was completed. Okay, so what are we going to talk about today? In the first part of this talk, I will inshallah talk about the legal foundations, legal basics of Islamic prayer times, and then I'll continue with the astronomy part of the talk. So we're going to talk about the astronomy of prayer times, and finally I'm going to conclude the talk by comparing prayer time calendars in Germany with each other. So let's begin with the legal foundations, legal basics. So here I will first talk about the definition of each prayer time and then continue to discuss prayer times at high latitudes. Starting off, I would like to define the prayer time of the midday prayer. And here we have a consensus among all schools, and the time of the midday prayer begins not when the sun reaches its highest elevation throughout a single day, but actually when the sun perceptibly begins to, set. So when the sun begins to lose height and begins to descend from its highest elevation, then the time of the midday prayer begins. And it's important to stress that this amount of the amount that the sun sets from its highest elevation needs to be perceptible to humans. So at this point, one might object, all right, so if I imagine the sun to be at its highest altitude throughout the day, I can imagine that it's possible for me to look at the sun and notice any change in its altitude in the explained sense, since I will be blinded by the sunlight. And this is actually the reason why in the books of Islamic law, in the fiqh books, in the literature, the time of the midday prayer is actually close to always defined through the shadow cast by objects. And in this sense, if we imagine after the sun rises, it begins to rise and elevate in the sky. And as long as the sun elevates and gets higher and higher, shadows are going to shrink, right? And once the sun culminates and reaches its highest point in the sky on this day, the shadow will actually shrink to its shortest length throughout the day. And as soon as perceptibly we can see a growth in the shadow of any object, right? Then we can basically, we can be sure that the sun has perceptibly left its maximum elevation and in this sense descended from its highest elevation, right? So that would be the beginning of the midday prayer. And the moment the sun reaches its highest elevation, in Arabic this is called istiwa. So the time period in which we cannot see any change in the length of the shadow, because it has, basically it has reached its shortest length within the course of a day. This period is called the period of istiwa. And then once the sun descends from its highest elevation, that is called zawal al-shams, and this is when the time of the midday prayer begins. So there is another reason for why I have introduced the shadow, because the time of the afternoon prayer is altogether defined through the shadow of objects. And this goes as follows. Let's imagine, so this is illustrated in this figure right here. Let's imagine we have an object of length L in the ground, and now when the sun, as explained, reaches its highest point in the sky and culminates, what we will have is that this object of length L has its shortest shadow throughout the day. This is called the zenith shadow, or dhillul istiwa in Arabic. So here I have just assumed that the shortest shadow has the length S. And now when the sun begins to descend and lose elevation, right? So it descends from its maximum elevation and approaches the horizon by the elapse of time, or with the elapse of time, what will happen is that the shadow is going to grow. And as soon as what has been added, or what the shadow has grown to, right, equals the length of the object itself, then the time of the afternoon prayer begins, according to the two most prominent students of Imamuna, Imam Abi Hanifa, rahmatullahi alayh, Imam Abu Yusuf al-Qadi and Imam Muhammad al-Shaybani, rahmatullahi alayhima, but also according to Imam Malik, Imam al-Shafi'i, and Imam Ahmed, rahmatullahi alayhim ajma'in. So once what has been added to the shadow is equal to the object that casts the shadow, so equal to the length of the object that casts the shadow, the time of the afternoon prayer begins, according to the scholars that I've just mentioned. But according to Imam Abu Hanifa, the time of the afternoon prayer begins a little bit later, because he, according to his opinion, the time begins when what was added to the shadow is not equal to the object's length alone, but twice the object's length. So what we need to find here is the moment at which the overall shadow length is equal to S plus 2 times L, right? And this will be when the sun has descended a little bit further and approached the horizon a little bit further, and then the time of the afternoon prayer will also enter, according to Imam Abu Hanifa, rahmatullahi alayh. Wonderful. Let's continue with the evening prayer, which basically has a very simple definition. The evening prayer, the time of the evening prayer begins once the solar disk has entirely disappeared from the horizon. So the upper limb of the solar disk needs to disappear from the horizon in order for the time of the evening prayer to begin. But here is one question that arises, and this would be the question about what exactly we regard as the horizon. And throughout the entirety of this talk, whenever I'm referring to the horizon, what I really mean is the line that we can see in both pictures shown here, right? It's this line, which basically in this picture separates the sea, the ocean, from the sky. So this is the reference horizon that is relevant for prayer times, which is also in some works of fiqh quite explicitly explained. And according to this horizon, in reference to this horizon, once the sun entirely disappears below it, not like shown in the left picture here, such that one can see half of the sun and only the center of the sun is at the horizon or below the horizon, but really when the solar disk has entirely disappeared, then the time of the evening prayer begins. This is going to be important later on, so you will understand why I'm basically stressing this so much, although it seems very easy. Okay, let's continue. Now assume that the sun has sufficiently set below the horizon. The sun has descended further and further, and at some point in time, we will have a picture of the horizon, which is basically as the picture that we can see at the moment. So we will see a red layer of light very close to the horizon. Above this red layer we will have yellow light, and right around it we will have this arc of white light, which basically is the outermost layer of evening twilight. And the time of the night prayer begins as soon as the redness of evening twilight, as shafaq al-ahmar, disappears. So the red light close to the horizon that we can see in this picture very well, once this disappears, then the time of the night prayer begins, according to, again, the Imamain, the two most prominent students of Imam Abu Hanifa, according to Imam Malik, Imam al-Shafi'i, and Imam Ahmed. Imam Abu Hanifa, once again, holds a different opinion, because he basically holds the opinion that not the red light needs to disappear, but the white light. So in other words, the entirety of evening twilight needs to disappear, because the white light would be the last trace of the sun that we can see, and once that has also disappeared, we cannot see any light of the sun any longer. So this would be the opinion of Imam Abu Hanifa rahmatullahi alayh. However, compared to his stance in the context of the afternoon prayers time, we find that Imam Abu Hanifa is not the only one that holds this opinion in case of the night prayers time, because we also know that according to one narration, Imam Malik held this position. So one narration within the school of the Malikis, that's what I'm talking about. One of the most prominent students of Imam al-Shafi'i, Imam al-Muzani, held the opinion that white light needs to disappear. And also it is narrated from Imam Ahmed that he held the position that white light needs to disappear in order for the time of the night prayer to begin. So in contrast to the afternoon prayer, in case of the night prayer, Imam Abu Hanifa is not too isolated with his position. All right. So let's imagine now that according to Imam Abu Hanifa, the time of the night prayer has also entered. So we cannot see any trace of the sun, no light of the sun whatsoever. And the sun is now further descending and descending, and at some point the sun reaches its minimum altitude throughout the day, and then it begins to rise again. And as soon as it begins to rise again, it will approach the horizon more and more, and at some point in time, due to its due to the fact that it approaches the horizon more and more, at some point it will be so close to the horizon that we can see a white light at the horizon, which very soon will break borders and spread to the left and the right horizontally. And this is the very moment that is referred to as al-Fajr al-Sadiq, basically in all four schools, right? So this will be the moment with which the time of the morning prayer begins. Exactly. However, here is within the Hanafi school, there is a discussion which addresses a subtlety of this phenomenon. Actually, what they discuss is the phenomenology of what I've just described, because what some Hanafi scholars discuss is if the first light that appears at the horizon, in the sense of when dawn breaks, if that light is actually first stationary and stays at one location for a certain amount of time and only then breaks borders and spreads horizontally, or if it immediately happens, right? So this is a discussion that we can find in the Hanafi school, and then it is discussed if consideration should be given to the very first moment this light appears, or if it actually is stationary for a certain amount of time and only then breaks borders and spreads horizontally, if we should then give consideration to the moment it begins to spread. And fundamentally this is a scientific question. It's a question related to the phenomenology of the break of dawn, and here we find that scientifically this can be resolved. And of course what we find is that the resolution that we find in the Hanafi school opinions that are basically matching this resolution that science tells us today. I'm not going to dig into the details of this. If anyone wishes to learn more about that, he or she is invited to basically check out the PhD thesis. And then after the break of dawn and the beginning of the morning prayers time, in this sense, the time extends until the sun rises again, which basically is an analogy to the sunset that I've just described. So as soon as the upper limb of the solar disk appears above the horizon, that very moment is already outside of the time of the morning prayer. And with that, basically, we have defined all relevant prayer times in a very non-detailed way. But as I said, if anyone wishes to see details concerning the different rulings that we have in the different schools and so on, this is all basically set out in the PhD thesis. So you are very welcome to read it. It's in English. So there is no excuse for, not reading it, because in Germany and in Turkey, people have excuses. Okay, so let's continue with the talk. The next matter that I want to address is the following. Let's assume we are at a certain part of the globe, which is sufficiently far in the north, such that the very instant the sun reaches its minimum altitude throughout the day would produce a picture at the horizon, as we can see in this illustration here. So neither redness, nor yellowness, nor whiteness will disappear throughout the course of a day. It's just there, even when astronomical midnight takes place and the sun is at its minimum. So in this sense, what happens is that the time of the night prayer does not exist. Not in the sense that we have not waited long enough for it to enter, but it just really doesn't exist within one cycle of 24 hours. Not there. What are we going to do? So this might appear like a very special, very modern question, which only came up within the last 100 or 150 years, because Muslims have moved further to the north and so on. But that's absolutely not the case. Why? Because the first time in history when Muslims were facing this problem was in the 10th century. Because back then, around the year 920, a Turkish ruler of the Volga Bulgars, his name was al-Maḥallī, he converted to Islam. So he did ihtida. And after converting to Islam, he basically sent messengers to the Abbasid Caliph, al-Muqtadir billah, and he told him, look, we are your subordinates and you need to take care of us. We have now converted to Islam and we don't know anything about the religion. We don't have mosques. We need people, architects that can help us build us mosques and so on. Please send a delegation with scholars, learned men and so on that can help us. So this was actually done, and one person that was in this delegation, Ibn Fadlan, his writings have reached us. His historical reports about this travel to the Volga Bulgars and what he's witnessed there, all of this is, more or less, all of this is preserved and has reached us today. It's edited. We also have manuscripts and so on. And that was actually the first time when Muslims have faced this problem. Because when he went there, he was supposed to actually be the learned man who has the answers to all the questions. But when he arrived there, he noticed that, okay, we came here with the objective of teaching Islam to these people, but now we are facing a problem that we don't know the answer to, because we've never seen that the redness of evening twilight does not disappear and persists through the night. So all of this happened in the 10th century, and this is why the very first ijtihadat, the very first legal rulings that we find to this matter, are also from this very time. And in a written sense, it's a little bit later. It's towards the end of the 10th and the beginning of the 11th century that we find written ijtihadat in the literature of the four schools. So in this sense, this is really not a modern problem, and we have literally 1,000 years of an intellectual discourse that we can study and that we can basically learn the relevant rulings from, which I will present in the following slide. So more generally, to put it more generally, what if the phenomenon that defines a prayer time does not occur? And due to the historical reason that I've just provided, this is particularly discussed for the special case of the absence of the night prayers time. And let's start, this is just ordered historically. Particularly rich is the literature of the Hanafi school. And the reason is that the Hanafis have a fundamental discourse on this matter. In what sense? In the following sense, the Hanafis discuss if the absence of the prayer time results in the non-obligation of the respective prayer. So this is a very fundamental discussion. And the main position that one can very clearly find in the Hanafi school is that a ritual prayer whose prayer time is non-existent, absent, basically becomes non-obligatory. So in case of the night prayer, performing the night prayer becomes non-obligatory. And I'm not going to discuss all the arguments provided and so on, because this would go far beyond the scope of this very concise talk. I can refer you to the PhD thesis again. But what I want to say is that the strongest arguments and the strongest advocacy of this position is due to Imam Muhammad ibn Ibrahim ibn Muhammad al-Halabi, the author of Multaqa al-Abhur and his famous commentary to Munyatul Musalli, called Munyatul Mutamalli, Ghunyatul Mutamalli. Wonderful. So Imam Halabi really, he is providing the strongest arguments in this sense, and I think one can also show this very clearly, that it's due to his arguments that the later scholars of the school, most of them at least, tend towards this position, and this position is more or less being established as the mu'tamad, as the main position of the school. The second position is that the obligation to perform the night prayer remains. Okay? And this position is most strongly defended and advocated for by Kamaluddin ibn al-Humam al-Siwasi al-Iskandari, the famous author of Fath al-Qadir, the muhaqqiq of the school, of the Hanafi school, rahmatullahi alayh. What is also very interesting about this is that al-Halabi's writing is a direct response to what Ibn al-Humam has to say on this matter. And I think this is also one of the reasons why al-Halabi's arguments are, have such a big weight in the later tradition of the school, because he is basically taking one argument after the other of Ibn al-Humam and tries to refute it. Exactly. So, okay, according to the scholars in category B, we know that the obligation remains, but this gives rise to another question. If I'm still, in the position to perform the night prayer, if I'm obliged with it, if it's compulsory for me, when exactly do I need to perform the prayer? And here we have to say that the main position of the Hanafis, of those Hanafis that say it is still obligatory, is that the night prayer is performed after the break of dawn. The rationale behind it is basically that, the time of Maghrib enters, and then we are waiting until the break of dawn, and the time of Isha does not enter, and now we have certainty that the time of Isha has not entered. And upon that point in time, it becomes compulsory for us, according to these scholars of the Hanafi school, to perform the night prayer in the sense of a make-up prayer as qada. This is the main position of the Hanafi school. This is also called taqdiru sabab. I'm not going to get into the details, but if you read the PhD thesis, you will see what I'm talking about. This is called taqdiru sabab, so referring to certain evidence from the Sunnah of our beloved Prophet sallallahu ta'ala alayhi wasallam. That's what they make out of it, basically. But there are also some isolated opinions. One opinion is that one should follow the methods of the Shafi'is, which I will present in a moment. Another opinion is due to the Ottoman scholar Abdul Halim ibn Pir Qadam, who is a muhashi, a commentator of Mullah Husrev's Durar. So he has written a gloss to it. And he has the opinion that the night prayer can just be performed within the time of the evening or morning prayer, either of them, right? But this is isolated, as I said. And one very interesting position is due to Ibn Amir Hajj, because he proposes a very specific taqdir method, so a method on how to determine an artificial time for the night prayer, for these nights of persistent twilight. And the details of it, I'm studying it in great detail, and I'm presenting a mathematical implementation of this method in the thesis. The details of it can be found in the thesis. So, as I said, the main position is qada after Fajr, but there are also some subsidiary positions according to which one would adopt certain taqdir schemes where a artificial time is being calculated for the night prayer. Okay. The last approach that we find in the Hanafi school is that basically both positions are regarded as valid because both have very solid arguments, right? And all of these scholars that I've mentioned, there are many more that have this approach, but those where I have given the names in bold characters, these are the ones where this approach is very clearly, explicitly formulated. So they explicitly say both positions are valid, right? For example, Allama Nuh Effendi, the famous Ottoman scholar who has written a gloss to Durer as well. Imam al-Tahtawi in his gloss to Durr al-Mukhtar, also in his gloss to Maraqi al-Falah. Ibn Abidin, of course, our beloved Ibn Abidin, rahmatullahi alayh, in Radd al-Mukhtar. Muhammad Abid al-Sindi in his commentary to Durr al-Mukhtar. And al-Laknawi in Naf' al-Mufti. So this is the situation that we find. But let me add something. A very common approach, especially of the scholars in category C, is to add that given that both positions are valid, of course, the more precautious position would be to perform the night prayer. This is also something that is added. For example, as Sindi says this, At-Tahtawi even leans towards the obligation, although he views both positions as valid, and so on. So very interesting discourse. If you wish to learn more about it, just check out the PhD thesis. Wonderful. So what do the Shafi'is say? In case of the Shafi'is, we find that there is no fundamental discussion, but there is much more a discussion of modality. The Shafi'is are, they have a consensus concerning the question if these prayers are obligatory, because they say, yes, it is obligatory to perform the night prayer even if its time is absent. But the question is, how exactly or when exactly am I supposed to perform this prayer? And the main position of the Shafi'is is to use the so-called aqrabul bilad method to determine an artificial prayer time. So what do they mean by this? And I'm specifically referring to what Az-Zarkashi describes in Khadim al-Rafi'i wal-Rawda. I think this has just been edited this work has just been edited within the scope of some academic works, but it's not really available as a book. So you would need to refer to the manuscripts that I've also cited in my PhD thesis. I've studied it on the basis of manuscripts. So in Khadim al-Rafi'i wal-Rawda, he says that the Akrabul Bilad method does not really mean that we need to go, let's assume we are in Duisburg in Germany and the time of the night prayer is now missing. We don't really go so much to the south that we reach the actual location where the time of Isha begins to enter, but we need to go further to the south where the nights in general never become never become anomalous, right? And what this really means, please, I refer you again to the PhD thesis, check it out, it's set out in great detail. But when we do this, then what we would do is the following. We go to this place where nights never become anomalous, right? And then for the specific day that we want to determine an artificial prayer time at the place where the time of Isha is missing, we would go down to this location and check out the time span between Maghrib and Isha at that location. Let's say it's 1 hour and 27 minutes. And then at our place in Duisburg, in Germany, in the north, where there is no Isha time, we would wait after Maghrib 1 hour and 27 minutes and then perform Isha. Maghrib would be very late. So that would be the Aqrabul Bilad method. So one problem about this method is that sometimes it can give artificial Isha times which are later than the break of dawn. And I will talk about the break of dawn in a minute. So what we need to do then is we need to switch from the pure Aqrabul Bilad method to the Aqrabul Bilad bin Nisba method. And the Aqrabul Bilad bin Nisba method basically says this. We need to go to this place, to this latitude where nights never become anomalous, right? Or non-regular. And then we again take the time span, 1 hour and 27 minutes. But now we calculate the ratio between this time span and the overall night length, defined as the time between sunset and sunrise of the following day. And then at our location in Duisburg, where the time of Isha is missing, we determine an artificial time such that the ratio to the night length in Duisburg would be the same as at the location where the nights never become non-regular, never become anomalous. That's the Aqrabul Bilad bin Nisba method, and this method is supposed to be used when the pure Aqrabul Bilad method gives Isha times which are later than the break of dawn. Wonderful. This is explicitly stated by Ibn Hajar al-Haytami in his Minhaj commentary, Tuhfa, for example. So then there is this second, opinion or situation, let's put it like this. And this ruling says that the respective prayer is made up as a qada prayer. But this only applies to certain situations. I should have maybe phrased it differently. But let me explain. This qada opinion only applies when, let's assume, we want to determine an artificial prayer time for Isha, but now the time between sunset and sunrise is so short, or sunset and the break of dawn is so short, that after performing the evening prayer after sunset, there is only left a very, very short amount of time until dawn breaks, such that the time of the morning prayer begins, and we don't really have enough time to place an artificial, the time spent between sunset and the break of dawn is not long enough to place an artificial time for Isha in it. Then what we would do is to make up the night prayer as qada according to the Shafi'is. This is what Ibn Hajar al-Haytami explicitly states, and that's basically the Shafi'i opinion in this matter. Wonderful. So what do the Malikis and the Hanbalis say? The main opinion of the Malikis and the Hanbalis is basically to follow the Shafi'is. They have not really discussed this matter independently of the Hanafis and the Shafi'is. And what we find is that basically all Malikis and most Hanbalis follow the Shafi'is by stating that the obligation remains and one must determine an artificial prayer time. In case of the Hanbalis, we have, okay, I see this is an and yeah, I have some, this needs to be and many more, this needs to be and, but however, I guess it can be understood because I've just given this talk in German as well. You can find it in the channel as well. So Buhuti is the only Hanbali prayer listed here, Hanbali scholar listed here. All other scholars are basically Malikis. But among the Hanbalis, we also have one scholar, al-Anqari, who has written a commentary to al-Buhuti's al-Rawd al-Murbi'. Let me stress that Buhuti is very important to the Hanbalis, right? Rahmatullahi alayh. He is one of basically the mu'tamad of the school. The main opinion of the school, the approved opinion of the school, is most often taken from his works. And al-Anqari has written a commentary to al-Rawd al-Murbi' where he, quite surprisingly from my point of view, takes the same stance as the main opinion of the Hanafis. He says that when the time of the night prayer is absent, the night prayer itself becomes non-obligatory. So very interesting. This position is also existent among the Hanbalis. Wonderful. So far we have only talked about the night prayer, but if we say that this is the darkest it gets in such nights, in nights of persistent twilight, there's another question that arises, right? And this question is, okay, what about the morning prayer? Because we've said it needs to get absolutely dark, and then we have the first light that appears and so on. So what about the morning prayer in these nights? And here we find that basically, so what about the morning prayers time in such nights? And what we find is that according to all four schools, there is a consensus that the break of dawn, al-Fajr al-Sadiq, is then given by the instant of astronomical midnight. By the instant the sun basically reaches or leaves its minimum altitude and begins to rise again. Why? The reason is quite simple. In all four schools, basically, al-Fajr al-Sadiq is defined as al-Bayad al-Muntashir fil ufq. So, white spreading light at the horizon. And if we now go back to this picture, the horizon is not only this part that we see. The horizon basically extends further beyond what is captured in this picture, right? And what we see is that located in the direction of the sun, we have this white twilight arc. But as soon as in such nights the sun will begin to elevate again and approach the horizon from under it, what will happen is that this white light will increase, and it will also spread to those parts of the horizon which are dark, right? And this is explicitly stated by many scholars. And in this sense, the very definition of al-Fajr al-Sadiq is satisfied. There is no discussion about it. I mean, al-Fajr al-Sadiq is white-spreading light at the horizon, and we have white-spreading light at the horizon in these nights, so wonderful. No problem. The time of al-Fajr al-Sadiq is given by astronomical midnight. And in case of the Hanafis, the earliest scholar to explicitly state this is Ibn Qutlubura. Ibn Qutlubura, rahmatullahi alayh, the scholar, the student of Ibn al-Humam, he has written a dedicated treatise, which I've edited in my PhD thesis, so you can check it out. And in this dedicated treatise to the absence of the night prayers time, which is called Nukhbatul Afkar fi Mas'alati Bulghar, he says the following. He says, فلأن من المسلمات في باب الإرصاد أنه متى نقص غاية ارتفاع نظير درجة الشمس عن 17 درجة فالنصف الأول من الليل حصة الشفق والنصف الثاني حصة الفجر. So very explicitly. So if we were to translate this, since it's among the accepted things in the discipline of observational astronomy, that as soon as the sun's minimum altitude is, its minimum depression angle is smaller than 17 degrees, so when the sun does not set to 17 degrees any longer, then the first half of the night is counted towards the duration of evening twilight, and the second half is counted towards the duration of dawn, right? So very explicitly he says that the first half of the night will then be the time of the evening prayer, and the second half will be the time of the morning prayer. Night in astronomical sense, so the time between sunset and sunrise of the following day. So wonderful. And if we look into the later literature of the Hanafis, for example, al-Rahmati in his gloss to Durr al-Mukhtar, al-Tahtawi says this explicitly, Ibn Abidin says this most explicitly, that very clearly this needs to be taken as the time for the morning prayer in nights of persistent twilight. And very, very similar texts can also be found in all other schools. Wonderful. So this is what classical Islamic jurisprudence has to say on this phenomenon of missing prayer times and so on. But if we look into various contemporary rulings, what we find is that they suppose to use artificial times for the night and the morning prayer in parts of the year despite the existence of their signs. So the actual signs, the disappearance of redness, the break of dawn exists, but still we do not follow the actual signs according to these contemporary rulings, but we use artificial times. And this is clearly, very, very clearly problematic, classically problematic in many respects, right? So I'm not going to dig into the details again. If you wish so, you can basically consult the book, the PhD thesis, and there I demonstrate on the basis of, usul al-fiqh premises on the legal theory of all four schools, it's not really compatible. Such a ruling is not compatible with classical Islamic law. And aside from these analysis, the sheer fact that in 1,200 years approximately, not a single classical scholar has ever ruled that the existing prayer times can be overruled by artificial times, simply due to the fact that it is perceived to be too hard, or because people tend to assume that it's too hot and so on. That's already, that already very clearly demonstrates that this is not compatible with classical Islamic jurisprudence. And also, in fact, what we find is that the opposite is explicitly stated in many texts, right? So, for example, Muhammad Abid as-Sindi explicitly says, even if you have to fast more than 23 hours, don't even think about, fasting according to taqdiri times, according to artificial times. Because as soon as the alamat, the signs exist, you have to follow them. Because it's mansus and so on. Check out what we have tried to say about this in the thesis. Wonderful. So, some of these some of these various contemporary institutions that have these, let's say, modernist approach to the matter, they also base their negligence of classical ijtihadat and rulings on the following supposed shortcoming of the classical ijtihadats, because they say that supposedly the classical ulama mujtahideen did not really know what they were talking about, because this is a very complex astronomical phenomenon, supposedly. And this can be very easily disproven, because we know for a fact that Islamic astronomers from the 13th century, and now I'm talking about works that have reached us, were capable of explaining this phenomenon quantitatively and qualitatively, or the other way around, right? Qualitatively and quantitatively. So Nasiruddin at-Tusi, for example, in at-Tadhkirah, very explicitly explains what this phenomenon is, persistent twilight, and when he expects it, where he expects it to happen, for how many days, and so on. And we even know that a proper understanding existed in the 10th century, so pretty much in the same century where Muslims first witnessed this problem. The second text is due to Jamaluddin al-Maridini, and Jamaluddin al-Maridini's text is important because if we read it, we will immediately notice something. Let's go through it, just one part. He says, فإن نقص ارتفاع النظير عن 17 درجة, it's not here, but in some manuscripts it is, فالنصف الأول من الليل حصة الشفق والثاني حصة الفجر. So very clearly, the sentence that we have just read from Ibn Qutlubah is pretty much the same as the sentence that Jamaluddin al-Maridini uses. So it's very clear that legal scholars, jurists, have not only address this matter, and it's not only the case that our astronomers have written treatises on this, but we actually see that our jurists have profited from these treatises and read these rasail and so on, in order to get an understanding of the problem that they want to find a ruling for. So wonderful. This very clearly demonstrates that our jurists have benefited from the astronomical literature on this matter. And then the last category, and I have to say I love him, rahmatullahi alayh, Sibt al-Maridini, Sultan al-Muwaqqitin, maybe the greatest prayer times calculator that has ever lived. May Allah be pleased with him. Sibt al-Maridini was not only an astronomer, he was also a leading Shafi'i jurist. He was a student of Ibn Hajar al-Asqalani, Sirajuddin al-Bulqini, Jamaluddin al-Maḥallī. So we are talking about someone who is far above most of those people that issue these contemporary rulings from today. Far above, in both disciplines, in astronomy and in Islamic law. And he is not even a rare phenomenon. We have many such scholars which were on one hand side astronomers and on the other hand side at the same time basically jurists, right? And if we see what Sibt al-Maridini has to say about this phenomenon, we find that his qualitative description, of course, is correct, because much prior to him people did this, but his quantitative description of this phenomenon, I'm talking about, upon which latitude we would expect which light, which color of light to persist and so on. He is 100% on point, on spot. So if you were to go to a modern physicist and ask him to explain us in detail the phenomenon of persistent twilight, this is the best you could get. And this is from more than 500 years ago. So this objection that supposedly our scholars did not know what they were talking about clearly is baseless. So it can very easily be disproven. Yes, rahmatullahi alayhim ajma'in, to all scholars of our tradition. Wonderful. So in this sense, the fiqh part of this talk is over now. We have covered a tiny bit of the fiqhi aspects of this matter. If you want to see details, as I said, I need to refer you to my PhD thesis. Now we will continue with the astronomy of Islamic prayer times. And here, the first thing that we need to basically be aware of is to understand that as explained, please don't worry about the equations. You don't need to understand any equation. I will just use them to explain things that you can easily understand. I'm promising it to you, okay? But the first thing we need to understand is that, as we've witnessed now in the fiqh part, prayer times are typically defined through solar phenomena. So the sun needs to set to certain, elevations, altitudes, in order for a given prayer time to occur, to begin. So the first question that I need to answer as someone that wants to calculate Islamic prayer times is, how can I calculate when the sun reaches a given altitude above the horizon or below the horizon? So if I, for example, want to know when does the sun set to 20 degrees above the horizon, let's say in Birmingham Sharif, okay? When does the sun set to 20 degrees above the horizon in Birmingham Sharif? I need to be able to calculate this, right? At which time does that happen? And in spherical astronomy, there is a standard algorithm for this, but it's crucial to understand that this standard algorithm is based on a model which does certain approximations that in the end lead to the final result found to be not exactly correct. So what I'm talking about is the following. If we look at this sketch on the left, this figure on the left here, this is the model that the standard algorithm of spherical astronomy used in order to calculate the times at which the sun reaches a certain altitude is based on. And in this model, the Earth is reduced to the point in the center of the circle where the mouse is now. The path of the sun in the sky is reduced to this line from S to S prime. So every point, each point on this line corresponds to one position of the sun, right? So that's one moment in time, and the sun will be at that position at one moment in time. So in other words, the sun is also reduced to a point. Then, due to the fact that the Earth is reduced to a point, the Earth's atmosphere is being neglected, but the Earth has an atmosphere. And another point is, so here are also some other assumptions that are astronomically wrong, but just, I'm just talking about, in principle, we can easily understand that this model is making approximations which in nature are not true. The Earth is not a point, the sun is not a point, the Earth has an atmosphere, and so on. Another point is, if we check the formulas, and we really don't need to understand them, what we find is the time that we would calculate depends on the latitude and the longitude. And if we take latitude and longitude and form a tuple, what we have is one point on the map. But prayer times are typically being calculated and distributed not for points on the map, but for areas, for cities, right? I would calculate prayer times for Birmingham Sharif and not for a point in Birmingham, right? So this is also a shortcoming of the standard algorithm. How do I need to go about this? That in the standard algorithm, I can only calculate prayer times for a point in a given city. And all of these shortcomings of the standard algorithm need to be addressed after calculating times according to the standard algorithm by taking into account all of the things that need to be corrected. And these corrections, historically, traditionally, within the scope of Islamic astronomy, are called Tamkin corrections. So the word Tamkin is being used here, and if we talk about Tamkin corrections, what we mean is really this, and not any additional buffer that we use in order to make our prayer times much more in order to be much more precautious in the context. No, that's not what we're talking about. These are not additional buffers that are being used. These are necessary corrections, okay? And I will go now through the main corrections that need to be included, and I will explain them qualitatively such that everyone hopefully can understand it within the next slides. So the first correction that needs to be taken into account is that, in fact, the Earth is not a point, but a sphere. So altitudes that have been calculated through the standard algorithm would be the altitudes that a observer in the Earth's center can see. But we are not in the center of the Earth, but we are on the surface, right? So we need to get up to the surface of the Earth, and this correction is being called the parallax correction. It's not really large, it's a small correction, it's 8.8 seconds, so 0.0024 degrees, not really large, but you know, we physicists, if we can calculate something, we tend to do it. Bismillahirrahmanirrahim. And given that it is possible to calculate this, it should be calculated. The next correction is much larger. It's the angular size of the solar disk, called alpha r. So, as I've said, in the standard algorithm, the sun is reduced to a point. So the altitudes that are being calculated through the standard algorithm of spherical astronomy refer to the sun's center. But in fact, especially for the time of Maghrib and Shuruq, so sunrise and sunset, what we need is that not the center of the sun disappears below the horizon, but the upper limb, the upper edge, right? So we need to actually take into account the angular size of the solar disk. This also plays a role for other prayer times, but for the details I need to refer you to the PhD thesis again. So concerning the value of the semi-diameter of the solar disk in the sky, what we find is that different measurements give this maximum value. So this is the largest measurement that we can find in the literature. And it reads 16 minutes, 16.42 seconds, which is approximately 0.271 degrees. And it's due to Emilio and colleagues, which have studied this, which have conducted this measurement in 2012. Wonderful. The next correction is a little bit more complicated. It's due to the atmosphere of the Earth, and the effect is called atmospheric refraction. So, as I've said, in the standard algorithm, the Earth's atmosphere is being completely neglected. So there is no assumption about the existence of an atmosphere at all in the standard algorithm. But in fact, the rays of the sun, when they enter the atmosphere, they are being more and more bent towards Earth. And this is the reason why when the sun rays reach the observer's eye, it seems as if the sun is still above the horizon, although it has set below it already. And this is a problem, because what counts, what we need to give consideration to in the context of prayer times, is what we see, not if geometrically the sun is set below the horizon or not. If I'm standing at the beach and I can still see the sun, that's what I have to give consideration to. So in Arabic it's called ra'yul ayn. And this is caused by the effect that I've just mentioned, which is called atmospheric refraction. And so we need to take into account that the standard algorithm that we use only gives us geometric altitudes. So we need to correct for refraction afterwards. But refraction is really tedious. Refraction cannot be straightforwardly calculated, especially not when the sun is very close to the horizon. So if the sun is, at large altitudes, approximately 5 degrees and higher, we can use this empirical formula, which is good enough for calculations. But if it's close to the horizon, we are lost. We cannot use any formula. But alhamdulillah, there are studies in which the near horizon refraction has been measured. For example, Shafi'i and al have done this in the early 1990s, right? So and they find this value. So this is the mean value, and this is the standard deviation. And if we use this value and then basically let statistics work for us and define a 99% confidence level and so on, we find that the correct value for refraction to be used is 1 degree. So 1 degree needs to be used. And now, historically speaking, Muslims starting from the 10th century on have typically used 1 degree for refraction. So they've done, alhamdulillah, Muslim astronomers have done, or Islamic astronomers have done everything correct. So we can basically stick to our tradition, and hopefully we will do everything correct. So this is a wonderful tawafuq. Alhamdulillah, we need to be thankful for our tradition. Wonderful. Let's continue. So this is what we need to use when the sun is very close to the horizon. So 1 degree would need to be, we need to use that for the times of Shuruq and Maghrib in particular. And for other times, if the actual altitude of that time is higher than 5 degrees, we would need to use this formula. The next point is, the next factor of Tamkin is, as I've said, we have seen that solar altitudes can only be calculated for points on the map. But prayer times typically are calculated for entire cities, so for areas on the map. And here we see the border of the German city Aachen, and I have put around the city of Aachen this rectangle here. Why have I done this? Because if we think about it, the only solution to this problem is the following. If we, for example, calculate the time of sunset of Maghrib, we need to calculate it for that point in Aachen in which Maghrib enters the latest, because then everyone in Aachen can follow it. And that will be, depending on the actual prayer time, depending on the day of the year, and so on, one of these corners. And I've derived an algorithm which automatically basically tells you which corner to use. It can be found in the dissertation. Right. Another factor is, so the cross here shows the administrative coordinates of Aachen, which is the Aachen Cathedral. And let me anticipate this already. Some calendars basically use the administrative coordinates of each city in order to calculate prayer times. So in case of Aachen, it would be, so the prayer times would be for the Cathedral of Aachen, which I don't know if it makes sense or not. So let me just mention this. Okay. Another point is, what we can see here is, in the sense of the background colors, the elevation profile of Aachen. Aachen is not flat. Aachen has higher points and lower points. And for people in, the lower points of Aachen, when the sun has set, this doesn't mean that people who live in the elevated parts of Aachen, that the sun will likewise have set there. That's not the case, because they can see deeper below the horizon. And this is also an effect that needs to be accounted for. This is called the height correction. And geometrically, I have shown it in this figure here. So the horizon that the standard algorithm uses goes through the center of the Earth, and this is called the geocentric horizon. In Arabic, it's al-Ufq al-Haqiqi. Then, when we correct for the parallax, we get to the surface of the Earth. That's called the topocentric horizon. In Arabic, it's called al-Ufq al-Sathi. And then, if we additionally take into account local elevations, so prayer times need to be calculated for the highest point in a city, just like in case of the fact that cities are areas and not points, we need to do it like this in order to make prayer times followable for everyone in the city, right? So if the sun has disappeared for the people in the highest, in the highest elevated point of the city, then it will have disappeared for everyone else as well. So we need to also use the highest point. And if we take that into account, we will get the solid line as the horizon. And this horizon is called apparent horizon, or in Arabic, al-Ufq al-Mar'i. Wonderful. And geometrically, using simple trigonometry, we can calculate the angle alpha h. And what we find is this expression here. So it's basically, it depends on the Earth's radius and the local elevation. And details, again, can be found in the dissertation. So the last factor that needs to be corrected for within the Tamkin framework is a little bit technical. If I go back, so we want to calculate this time t when the sun reaches a given altitude h. But this time depends on the quantity E and the quantity delta. So this is the equation of time. I'm not going to explain these quantities. And this is the so-called declination. These two quantities in turn depend on time. So what I'm trying to say is the correct value that I must use for E and delta are the values that they have when the sun reaches 20 degrees. But I don't know when the sun will reach 20 degrees because I'm trying to calculate it. So I need to know when the sun reaches 20 degrees in order to calculate when it reaches 20 degrees. So I have a problem. So the solution to this problem is to use an iterative method. So what we do is we use the initial values of delta and E. We calculate a time for when the sun reaches 20 degrees above the horizon, for an example now. And then we use the time that we have obtained to recalculate the values of delta and E, and then we recalculate the time when the sun reaches 20 degrees, and so on. We do it as many times as required until the final time that we obtain doesn't change within the margin of precision, or within the precision that we basically demand. So if I, for example, say I want to calculate prayer times up to a precision of, let's say, 1 millisecond, then I would repeat this iterative procedure as many times as it is necessary in order for the time that I obtain to not change within 1 millisecond any longer. And then I have the final result. So this would be an iterative procedure that must be employed for delta and E. This is the ideal. So that's how Tamkin corrections must be calculated. There is no discussion about it. This has also nothing to do with theological assumptions or anything. This is just science. If someone does this wrong, he does it wrong. There is nothing, it's not like in theology that we can say, well, he has different paradigms or anything like that. Doesn't work. It's just rock solid science, okay? But how do most calendars handle the Tamkin corrections in practice? Unfortunately, we find that the hate correction, without S, the hate correction is ignored by most calendars. Then atmospheric refraction and the solar angular size are only considered conventionally. So they only use conventional values. What do I mean by conventional values? At some point in time, due to historical reasons, for facilitation of certain applications, one has just adopted to use 35 minutes, so it's a little bit more than 0.5 degrees, for refraction. Although we know for a fact that refraction can be much larger, and although we know that the correct value to use, as I've shown, for Maghrib and Shuruq is 1 degree, right? Then for the angular size of the sun, they use 16 minutes. And if we add this, we get this 0.83 degrees, which, the refraction alone should be 1 degree. So we are really not correct with this, right? Then concerning the fact that the declination and the equation of time change throughout the day, what most calendars do is they simply use the initial values that these functions have at the beginning of the reference day, right? So they do not bother doing this iteration and so on, although they should. Then the fourth point, which I've already mentioned, they simply use administrative coordinates. So they use certain APIs and take the latitude and longitude that these APIs give, right? So in case of Aachen, it would be the coordinates of the Cathedral of Aachen, which, as I said, really doesn't make any sense and I think is kind of ironic. Okay. So this is the way many calendars calculate, for example, the time of Maghrib. If we now compare this to the full calculation, where each and every Tamkin correction is considered correctly, how much of a difference do we get? This is shown in this plot in minutes. So the y-axis shows in minutes the difference, and we see this for Berlin for the calendar year 2024. And the different colors show the different effects, right? Red is refraction, yellow is hate correction alone, blue is topological corrections, and green is iterative corrections. And if we sum all of these corrections, then we get the total mistake that we basically make if we only adopt this conventional calculation scheme. And we see that for Berlin, the total error, the total mistake can be as large as 10 minutes on Maghrib. This means that Maghrib is 10 minutes earlier than it actually is. So Maghrib is being calculated wrongly, and the amount of error that one has is, so the deviation that one has is up to 10 minutes. And this is really a lot, right? So in this sense, it is highly problematic to adopt this conventional approach to certain Tamkin corrections, if they are considered at all. Some calendars even do not consider these effects conventionally. So I do not even want to talk about these prayer time calendars, but these are not a lot. These are not many. There are only a few like this. But most calendars only consider Tamkin conventionally, and then what we find is that their Maghrib time, for Berlin at least, will be at least four minutes earlier always, and sometimes up to 10 minutes earlier than it should really be, right? So not considering the Tamkin corrections as they should be considered and calculating them correctly can cause a difference of up to 10 minutes in the Maghrib time of Berlin. Wonderful. Let's leave it there. All right. So in this sense, we have now understood how to calculate solar altitudes. within the framework of calculating prayer times. So we have now understood that we need to take into account these Tamkin corrections and so on. But what we have not discussed so far is how far the actually needs to elevate above or set below the horizon for certain prayer times to occur or to begin, right? This is another question. And here we need to, or we can identify two categories. The first category is given by prayer times whose altitude can be calculated purely mathematically, geometrically. And this is the time of Dhuhr, of Asr, according to both definitions, of Maghrib and Shuruq. But the altitudes HI and HF of the night and morning prayer of Isha and Fajr, that's why I've used I and F, these must be determined through observational studies. So what I need to do is I need to perform observations, conduct observations, right? I need to perform sightings, and then I basically note and write down at which time the redness of evening twilight has disappeared. And I'm doing this 1 time, 10 times, 100 times, 1,000 times, and then I have, sufficiently enough data, and I can employ basic statistics, and then I can say, okay, at a given confidence level, the break of dawn always occurs when the sun reaches this and that elevation, or approaches the horizon, up to this and that degree, or sets to this and that depression, whatever. Okay. So this is the way that we need to go for Fajr and Isha to find their altitudes. And the conditions for the validity of observations, of course there are conditions, right? If I say I have conducted observational studies, of course I need to satisfy certain conditions in order for these observational results to hold validity. Otherwise, they need to be disregarded. And the main conditions are the following. The first is, given that after sunset, the disappearance of redness and the appearance of whiteness, the break of dawn, will happen in the entire northern direction. I'm talking about, the half circle of the northern direction, right? We need to ensure that the entire horizon is free in that direction, because redness will disappear somewhere between west and north, and whiteness will appear somewhere between north and east, right? So we need to ensure that the horizon, in the way that I've defined it at the beginning of this talk, needs to be apparent to us and visible. There may nothing be covering it, like buildings or, trees and anything else. So no obstacles. The second condition, the observing person must be competent in Islamic law and in spherical astronomy. Why does the person need to be competent in Islamic law? The reason is very simple. If you don't know enough about Islamic law, if enough about fiqh, you don't really know which phenomenon you are searching for, right? So you need to be aware of the fact that according to the Hanafis, whiteness needs to disappear. According to the Shafi'is, redness needs to disappear. According to this, you know what I mean? So clearly you need to be, you need to have enough competency in Islamic law, in fiqh, in order to understand what you are actually looking for. The second requirement, being also competent in spherical astronomy, is apparent because let's assume we are conducting a sighting of Fajr. It's absolutely dark, and now I am supposed to look into the direction of the sun, but I can't see anything of the sun because it's absolutely dark. And the first light of dawn, of course, will be visible right above the spot of the sun below the horizon, because the sun is below the horizon at a given spot, and right above it, the first light of dawn will appear once the sun has approached the horizon sufficiently, right? So that's what's going to happen. But how can I, as someone who doesn't understand anything about spherical astronomy, find the actual direction of the sun below the horizon if I'm not competent in spherical astronomy, right? So I cannot see anything of the sun because the first thing that I will see is the break of dawn, right? So clearly I need to be also competent, and I need to have knowledge about spherical astronomy in order to be able to calculate where the sun is below the horizon. And now the final and really crucially and most important condition, this is extremely important, is the absence of light pollution. What do I talk about when I say light pollution? I'm talking about anthropogenic light pollution. Light pollution describes the following. We humans, we do not live in we live in a world where we really pollute the night sky. In the following sense, we have, we have city lightings, we have housing lightings, we have car lights that really produce a lot of artificial light, aside from what we have due to stars and the moon and so on, right? We have a lot of light that we humans produce. And this light does not really disappear. It forms, something like a half sphere, a semi-sphere, around each and every city where we have light pollution, and pollutes and increases the brightness of the night sky. So what we perceive as dark when we can't see anything of the sun any longer, that's not really dark, because if that was really dark, we could see the Milky Way, we could see certain galaxies and so on. But I bet no one of us has ever seen the Milky Way or anything in the sky. And that's due to the fact that our night skies are basically polluted by artificial light. And performing sightings under such light polluted skies is problematic. Why? Because we will not really see the break of dawn, but what we will witness is the moment the intensity, the brightness of dawn becomes larger than the brightness of the light pollution of the sky that we are performing or conducting the sighting at. So we will not really see the first light of dawn. We will see that amount of dawn that is brighter than the artificial brightening of our night sky. And that's a problem. And what we see in this figure here is Europe in the Light Pollution Atlas of 2022. And here, this parameter rho basically tells us how large the light pollution is. And really dark, really dark, so 100% absent light pollution. So we have a naturally dark sky where this map is black. Okay, so we see that Europe is really close to entirely lost when we talk about performing sightings. Close to entirely lost. And this only shows the zenith brightness. What we actually need is the horizontal light pollution, and that's even worse. So if you want to see details, I would need to refer you to my PhD thesis again. What we here see is only the zenith brightness, and the horizontal brightness is even worse. So really bad. So conducting sightings in Europe is not really possible. So now we have seen these conditions for sightings, and I will now show an example of how one should really not perform sightings. All right, this is a video. Let's watch it. I have basically removed anything that shows us from which institution this was, because I don't want to attack anyone. So let's go through it. The first mistake that they do is they perform their sightings, they conduct their observational study in Zandvoort. Zandvoort is pretty much here. This is, I'm not exaggerating, for a fact, this is the brightest place in Europe in terms of light pollution. I think the night sky there is, I think it's 18,600% brighter than it would be naturally. So truly the worst place where you can conduct this observational study. First mistake. Second mistake, I'm going to go to the back. Okay, so second mistake, the sun has set to the right of the center of the picture, right? The center of the frame. It is set to the center of the frame. So even at the beginning of evening twilight, the camera does not really capture, that is not really focused on where it should be focused, because it should always have the sun in the center and it should go with the sun. And if I go back now, again, last time promised, we see that the sun is setting like this, right? So it drifts to the right while, descending. But the camera is basically still focusing on where the sun set. So now they are fast forwarding for 1 hour and 15 minutes, and then they are stopping the time, And in Turkish, they are now saying that the time of Isha has come. So many mistakes. Let me begin with this. As I've said, the sun has drifted further and further to the right. So, in fact, as I've said, they have fast forwarded 1 hour and 15 minutes. The sun is now out of the frame actually, and the camera would need to actually follow the sun, because you need to focus on where the maximum of the brightness of the sun is in order to see if redness has disappeared or not, right? So really hard to understand why they would fix their frame on where the sun has set. And then another mistake, if we take a quick look at what we see at the horizon, despite the fact that they are not even focusing on where the brightness has its maximum, we see clearly, we can even see the horizon here, right? We see the horizontal line, and we can clearly see redness, and above it we can see yellowness, and above it we can see whiteness. So what exactly are they talking about when they are saying that the time of Isha has come? If I would not know, and I know if you see the entire video, you will see that they themselves state that redness needs to disappear in order for the time of Isha to begin. So how can they come to the conclusion that the time of Isha has come when clearly, despite all of these mistakes and shortcomings, even when looking into the wrong direction, we can see redness here, albeit the fact that, you know, the light pollution at this location is the highest in Europe, and the night sky is 18,600% brighter than it would be naturally, we can still see redness. So this is really not how sightings should be performed. Absolutely catastrophical here. So that's a travesty. And what you get is this result. This photo was taken at the Isha time that the calendar that did this sighting that I've just shown has published. So very clearly we can see, we are seeing this photo for the second time now, very clearly we can see that neither redness, nor yellowness, nor whiteness, nothing of evening twilight has disappeared, so we cannot really talk about any Isha time here. Very clearly. Wonderful. So this is really not how it should be done. So the next question that arises is, okay, so given that we have such a large light pollution in Europe, what should we actually do? So how can we perform, or how can we find which angles we need to use for Isha and Fajr, for the morning prayer and the night prayer? And the solution is that we have a certain group of people for whom all of these major conditions that I've just mentioned are basically fulfilled. And these are Islamic astronomers. Why? Because these astronomers, you know, they received education at madaris, at madrasas, right? And in madaris, you typically, and most importantly, first of all, learn your religion. So madaris, clearly someone who has learned astronomy at a madrasa, 100% will have also studied fiqh and tafsir and hadith and so on. So it's very clear that we are talking about persona who have not only studied either only the religion or only astronomy, but clearly have studied both, and given that they have conducted sightings, alhamdulillah, very well. Concerning the absence of light pollution, most of these astronomers have lived in times where there was no such thing as anthropogenic light pollution, right? There was no such thing 1,000 years ago when Ibn Yunus lived there. There was no industrial revolution which caused xenon lights and you know, LED lights and so on. Nothing like that. So it's very sure, and we can very easily understand that during the times of most of these, close to all of these Islamic astronomers, there was no such thing as anthropogenic light pollution, and thus their results are very, very relevant for us. Okay. So in this sense, their results are particularly relevant for us, but this gives rise to another question. Okay, it might be that they qualify in that sense, but can we also assure that their results are reliable? In the following sense, I mean, if someone has lived 1,000 years ago, science has quite evolved, is there a guarantee that this person who has lived 1,000 years ago had the correct formula, did, you know, conduct his sightings correctly, and so on? Can we kind of assess that? And in this sense, I want to demonstrate that indeed their results are highly reliable. I want to demonstrate this using the example of the time span between al-Maghrib and al-Isha. So if we were to calculate it in modern astronomy, we would use this formula that we see here, this equation, to calculate the so-called hour angle between Maghrib and Isha. This is what we would employ. And in comparison, in the lower left here, I show an excerpt from the most influential treatise on the astronomical quadrant. The astronomical quadrant is an instrument that I show on the next slide. And this treatise was written by Sibt al-Maridini, Sultan al-Muwaqqitin, rahmatullahi alayh, and it's called al-Risalatul Fathiyya. This is from a private manuscript. It's somewhere in the shelf behind me. And so what we see here is chapter 12. But in earlier chapters, Sibt al-Maridini has defined certain functions that he uses here. I'm just going to name them. The first function that he uses is Bu'd al-Qutr, and this is the sine of phi times sine delta. Then he uses the function Jayb Yazay. Jayb is just sine, and Yazay is an abjad 17 degrees. Then he uses the function al-Asl al-Mutlaq, which he defines as cosinus phi cosinus delta, so cosine phi cosine delta. And finally, he uses the function nisfu qaws al-layl, which is the semi-nocturnal arc in English, and it is defined as the arc cosine of tangents of phi times tangents of delta. Wonderful. So using these functions, he describes how to use the astronomical quadrant to calculate the time between Maghrib and the disappearance of redness as follows. This is the quadrant. This is actually a quadrant which was made by Shamsuddin al-Mizzi, another astronomer, important astronomer of the 14th century, rahmatullahi alayh. And a quadrant has typically two sides and one arc. On these two sides, we have two scales, one direct and one indirect scale. So the direct scale begins at the bottom with 0 and has a 1, on top, at the top. And the indirect scale is the other way around. Then the same at the bottom here. So we have two scales, 0, 1 and 0, 1, from left to right and right to left. And then the arc likewise has two scales, one direct and one indirect, or direct and inverse, if you wish so. So the direct scale begins at the bottom, 0, and has 90 degrees up here. And then we have 0 degrees up here and 90 degrees at the bottom. Typically, there is also a thread. That's the word that I was looking for. Typically, there is also a thread that comes out of the origin of the two sides of the quadrant. But in this specific example, it's just not there. But I have painted it into what I'm going to show within the next slides. So using this or referring to this instrument, Sibt al-Maridini now says the following. Chapter 12 addresses the amount of the durations of evening, twilight, and dawn. Add Bu'd al-Qutr to the sine of 17 degrees, and what you get is the al-Asl al-Mu'attal for evening, twilight. So the first thing we need to do is add sine 17 degrees to sine phi sine delta. And once we do this, we obtain a value which he calls al-Asl al-Mu'attal. The next step is now place the thread on al-Sittini. Sittini is the name of the y-axis. Place the marker on al-Asl al-Mutlaq. So he wants us to calculate the value of al-Asl al-Mutlaq. So our latitude phi, cosine of our latitude phi, times cosine of the declination of the day we perform the calculation for. And then when we get a value, he wants us to place the marker, shown by this white ellipse here, onto the value of this function. And the next step is move the marker with the thread to al-Asl al-Mu'attal regarding the horizontal sine values. So he now wants us to take this thread and, move along the arc as long as it is required in order for the marker to reach the value of this subsidiary function, which he had called al-Asl al-Mu'attal. This was the first thing that we have calculated. And then he wants us to subtract what the thread has swept out of inverse angles. From what? I will come to this later. So he wants us to get this angle alpha, right? He wants us to read off what the thread has swept out of inverse angles. So basically this angle. So using the quadrant, we could just read it off. But mathematically, it's this angle alpha. And using basic trigonometry, we can see that the cosine of alpha, given by the adjacent side divided by the hypotenuse, we find that it's given by sine 70 degrees plus sine phi sine delta divided by cosine phi cosine delta. So since we are not interested in the cosine of alpha, but alpha itself, we would need to take the arccos cosine, right? The inverse function. Wonderful. So now we need to subtract this from what? From nisfu qawsil layl, from the semi-nocturnal arc. And what remains is the duration of evening twilight. So we find that Sibtul Maridini very clearly describes and actually applies this modern formula that we had seen here, right? So very clearly he has described and applied this formula. Wonderful. So we know for sure that Islamic astronomers had access to the correct formula that we also use today when calculating the time span between sunset and the disappearance of redness. The second question that follows is, okay, it might be that they had the correct formulae, but, calculating tangents of phi times tangents of delta and the arccos cosine of that, and then, all of this 1,000 years ago without a calculator, was that possible? And if yes, how precise was that? Very valid question, right? So we need to also clear this. And concerning that, I'm going to show you a prayer timetable compiled by Ibn Yunus, who lived in the 10th century. So most probably this table was compiled around the year 950. And what this table shows is exactly the function that we have just seen. So Ibn Yunus has calculated the time it takes after sunset until the redness of evening twilight disappears for Cairo for an entire year. So Cairo is at latitude 30, and he has used 17 degrees. I will come to this later, so wonderful. And what we see here is this first column basically shows the ecliptic longitude of the sun. The ecliptic longitude, I'm not going to explain it, but you can roughly understand this as the day and the year, okay? And these columns basically show month, and the months are grouped by pairs. Always 2 months are grouped. And here we have an inverse scale for the days. This is because the problem is actually anti-symmetric with respect to the solstices, right? So for details, I need you to refer to my PhD thesis for details. But Ibn Yunus basically has used the anti-symmetry of the problem entirely. But what does he give here? He gives us in equatorial degrees. He says, this entry here basically corresponds to approximately the 21st of March. The 21st of March, he says that the hour angle between Maghrib and Isha is 19 degrees, ya and ta, typically no dots in abjad, and then mim ha minutes. So 19 degrees and 45 in abjad, mim ha minutes. 45 minutes are 0.75 degrees, so 19.75 degrees. We need to multiply this by 4, then we get the time, which is 1 hour and 19 minutes. So 1 hour and 19 minutes after sunset, according to Ibn Yunus, 1 hour and 19 minutes after sunset, the redness of evening twilight will disappear on the 21st of March in Qahira, in Cairo, right? So this is basically the prayer timetable that he has compiled. I have transliterated and recalculated this prayer timetable in my PhD thesis. And here is the entry that we have just read. And I have also indicated how much of a difference I find. So I have exactly calculated what Ibn Yunus intended to calculate, and using modern calculators. And what I find is that the largest mistake, so the exponent, what is given in some exponents here, is the mistake that Ibn Yunus does. So we need to add these values in order to get the correct value, right? And what we find is that the largest mistake that Ibn Yunus does is equal to 2 arc minutes. 2 arc minutes translates to time as 8 seconds. This means that Ibn Yunus has evaluated the expression that I've just shown with an incredible accuracy of 8 seconds. Wonderful. So very clearly we see that Islamic astronomers did not only know the correct formula, but they were also capable of, and we're talking about the year 950. This is a very early time also for Islamic astronomy. They were capable of evaluating these formulae with sufficient precision. Alhamdulillah. Wonderful. All right. So the final question that remains is, now we know that they are trustworthy, what did Islamic astronomers actually say about these angles, right? And so which values did they find for HF and HI? And in order to find an answer to this question, I have performed a very extensive literature review in which I have studied more than 1,350 manuscripts of Islamic astronomy, spread all over the world. And what I find is that in terms of the history of science, the history of this question, we can identify 3 traditions concerning these 2 angles, right? The first tradition is the tradition of the mutaqaddimun. This is not the entirety of the earliest astronomers, but this is a famous group among the earliest astronomers that we have. And this group includes people like al-Khwarizmi, Habash al-Hasib, al-Nayrizi, and so on. But this tradition is kind of problematic. Why? Because we know for a fact, and I'm showing this in the PhD thesis, that they have used a wrong formula when calculating back on the basis of their observations how far below the horizon the sun was during the phenomenon that they've observed. So they have basically used the wrong formula. And quite interestingly, if we analyze how large the uncertainty was that the mistake was, the error was that they made due to using a wrong formula, we find that their observations are actually agreeing with this final tradition, which, as I will explain, is what I find to be correct. Okay? Another problem of the Mutaqaddimun tradition is that it is unclear to which Isha they were referring to. As I've said in the beginning, there are different understandings of the time of Isha. Some scholars say redness needs to disappear. Some scholars say whiteness needs to disappear. There are even some scholars, I've not said that, but they find that, they think that, or they opine that yellowness needs to disappear. So what are they exactly referring to when they say 18 degrees? So the tradition of the Mutaqaddimun is not really sound in this sense. Another tradition is that of the so-called Mutaakhirun. They have used 20 degrees for Fajr and 16 degrees for Isha. And this tradition goes back to Ali al-Marrakushi. However, al-Marrakushi himself states that, 19 degrees and 17 degrees might be correct instead. So he's not very decisive, right? And I think this is the reason, one of the reasons, why his standard, his tradition was really short-lived. And it was also locally confined to Egypt, basically. And we see that scholars such as Mizzi, whose quadrant we had just seen, who was a direct student of al-Marrakushi, has basically broken with this tradition and adopted 19 and 17 degrees. Because on the basis of his own observations, he has found, okay, what my beloved teacher al-Marrakushi has said doesn't seem to be very correct, so I'm going to go with 19 and 17 degrees. Although we have to say, as I've already said, that al-Marrakushi himself was also not very decisive. And finally, the Mazhab, the tradition of the Muhaqqiqun, they say 19 degrees for Fajr and 17 degrees for Isha. This goes back to the Banu Musa, al-Buzjani, Ibn Yunus, al-Biruni. These are just the earliest scholars. We also have fuqaha who say this, right? We have seen Ibn Qutlubu'a. We have al-Hattab of the Malikis. We have Sibtul Maridini of the Shafi'is, and so on. The list goes on and on. In my PhD thesis, I have a list which extends over 31 pages and collects all of these opinions, right? And one, particularity of this madhab, of this tradition, is that many of these scholars explicitly support their results through sightings. Ibn Shatir, for example, explicitly states that he has observed these phenomena for years, and he finds that 19 degrees and 17 degrees are correct. And on the basis of this soundness in terms of empirical data, we find that there is a consensus which is at least 600 years old within Islamic astronomy concerning these parameters. And if we look at this figure on the right here, I have given an overview of all the opinions that I've collected. In total, it's more than 420 opinions that I've collected. And, you know, the red column shows the opinions concerning the angle of Isha, and the blue columns show the opinions concerning Fajr. And what we see is that very clearly, very clearly, the absolute majority of scholars has preferred to use 19 degrees for Fajr and 17 degrees for Isha, which again stresses this consensus. And in the context of this consensus, let me stress this, you know, using everything that at least I could find, each and every treatise and timetable that we find, and analyzing everything that has reached us in this sense, there are even some centuries, 100 years, where there was not a single scholar who has said anything different than 19 and 17 degrees. We have such centuries if we analyze it. Again, I need to refer you to my PhD thesis where all of this is detailed out. Okay, so now we have established that according to our own tradition, 19 degrees and 17 degrees are the parameters to use when calculating these two times. But one might ask, quite validly, all right, this might be what our tradition says, but what does modern science say? And the first thing that we need to get rid of in this sense is the myth. I'm stressing it, it's a myth that supposedly it was scientifically established that astronomical twilight begins at 18 degrees. Why? Because if we look into the actual scientific literature, astronomy literature, what we find is that this is a mere convention, explicitly stated in the Astronomical Almanac, for example. And this convention goes back to the German physicist, astronomer Johann Heinrich Lambert. He has written a fundamental work for photometry, which is called Photometria in Latin. And in this work, he starts his discussion of twilight by stating that according to the usual assumption, twilight either begins at 19 degrees or 18 degrees, and then he simply uses 18.5 degrees in his own calculations. And as conventions are there to facilitate, later on, you know, Western physicists, astronomers, basically got rid of these decimal points after the comma and reduced it to 18 degrees. That's one point. Now the second point is, if Lambert himself states that according to the usual assumption, he needs to refer to someone. And who does he actually rely on when saying this? Even according to Western astronomers like Ernst Anding, who translated Lambert's work to German, from Latin to German, it is very clear that Lambert here relies on Muslim astronomers, and in particular on Ibn Mu'adh al-Jayani. Because Ibn Mu'adh al-Jayani has written a treatise on twilight in which he exactly states what Lambert states, because he says that there are two opinions, 19 degrees and 18 degrees, but Ibn Mu'adh al-Jayani, in his own calculations, uses 19 degrees, and by doing that advocates for this parameter, right? And finally, Lambert himself in his work, in Photometria, conducts an observation, and this observation yields 19 degrees. So really, this is just a myth. There is no, you know, there is no profound, it is not backed up by any profound evidence that it was scientifically established to be at 18 degrees, astronomical twilight. Quite the contrary, if we check actual naked eye observations of twilight that were conducted within the last 150 and 200 years, what we find is that people like George Jones, who has conducted 328 observations, Gustav Hellmann, Paul Gruner, very important, Friedrich Schmidt, who has conducted more than 1,372 observations within a course of 24 years. So he was interested in the zodiacal light and al-Fajr al-Kadhib, and has studied this for 24 years and has performed close to every night sightings of this phenomenon. And due to the nature of this phenomenon, he has also basically observed twilight, right? And then also we have Mu'tasim Yazıcı, a Turkish naval officer, who spent 15 years of daily twilight observations, or conducted 50 years of daily twilight observations at sea. That's what he personally states. And all of these studies commonly in consensus, state and show that the correct angles associated with the break of dawn and the disappearance of redness at the horizon are 19 degrees and 17 degrees, right? So wonderful. Basically, what we find from our tradition is backed up by modern scientific results as well. Perfect. Now the final thing, as I'm a theoretical physicist, is it possible to somehow also motivate these values on the basis of first principles? This is more or less, within a given uncertainty, possible for the angle of Fajr. We can estimate the angle of Fajr on the basis of a geometric model of twilight, of the break of dawn. And this model is shown on the left. Here we have the rays of the sun coming from the right. The gray part shows the Earth's, so the atmosphere of the Earth. And at the outermost part of the atmosphere, the sun rays are being reflected such that they reach the eye of the observer, which is located at the point O here, right? So using the geometry of this problem, we can basically find this expression for the angle of twilight. And now the only question that remains is, we know how large the radius of the Earth is, but how large is the relevant, how high is the relevant layer of the atmosphere where these scatterings that cause the light that we see during dawn take place. And we know for a fact, this is established, that the mesosphere is the relevant sphere of the atmosphere where these scatterings take place. And the boundary layer of the mesosphere, where the mesosphere ends, is the mesopause. So we need to find the height of the mesopause and plug it into this formula in order to get the angle of Fajr. And concerning the height of the mesopause, we find, or studies find, that this height changes bimodally between two levels. So it's not that it gradually reduces from 100 kilometers to 65 or 86 kilometers. It's not gradually, but it's like discrete. It jumps from 100 kilometers to 86 and then back and so on. And it depends on the actual day of the year and your actual latitude, how often that happens and when exactly that happens, okay? But it's sure that across the globe, these are the two levels that we have, okay? And using these values, we can get this window for the Fajr altitude, which quite well, actually excellently agrees with all the empirical data that I've just presented, right? So we had seen that some say 20 degrees, some say 18 degrees, but actually most of them, close to everyone who has actually engaged in astronomy, says 19 degrees, right? And 19 degrees lies exactly, more or less exactly in the middle of this window. And we also find that, as I've said, all the other values are also either in the window or very close to this window. So in the sense of a motivation of how, or for, let's put it this way, in the sense of a motivation for why these values that I've just provided should be correct on the basis of first principles, this is enough. This is not good enough to actually calculate it, but to provide additional motivation, wonderful, no problem. Okay. Bismillah. So having also provided this motivation, we are basically through, we have finished. Why? Because now we have the ideal. Now we know how prayer times should ideally be calculated. We have addressed all the fiqh aspects, all the legal aspects. We have discussed how altitudes are being calculated. So we need to include these Tamkin corrections and so on. And we have also discussed how which altitudes actually correspond to certain prayer times. Perfect. We have everything. So this means we have now the ideal how prayer times should be calculated. And now we want to compare this ideal with actual prayer time calendars that are being used in Germany. I think most of them also being used in the UK and the US. But yeah, it's 5 calendars that I analyze here. I think many other calendars also follow principles that I show here. So this should not be only interesting for people that live in Germany. So this list here is sorted alphabetically. Let's start with the Diyanet and the Hijrat calendars. these calendars used to be different, but they, basically united their calendars back in 2023. This calendar does not use or does not calculate Tamkin. Instead, it uses fixed, so it performs this conventional calculation that I had just shown, and then it uses fixed buffers of 7 minutes for Shuruq and Maghrib, 5 minutes for Dhuhr, and 4 minutes for Asr. If we go back, I had already explained this, but if we go back and if we apply this to Berlin, this would mean that their time would always be here. We have to imagine a line with 7, because this is Maghrib, they use 7 minutes, we would have a line here. So at 7 minutes. This means that when the Tamkin corrections are maximal, there would be a difference of 3 minutes. And at some parts of the year, their Maghrib time would be unnecessarily late. So if I were to fast on these days, I would unnecessarily lengthen my fast without a reason, because these things can be calculated. So it really does not make any sense for why one should adopt these fixed buffers, right? Because these things can be calculated, as I've just demonstrated. Right, so problematic from my point of view. Secondly, concerning Fajr and Isha, they use 18 and 16 degrees. Again, problematic. We have just established that 19 and 17 degrees are correct. Even more problematic is that they only use this in parts of the year. So problematic if we, if we consider classical paradigms. Because as I've said, what they do is they only calculate Fajr and Isha in parts of the year, because beginning upon an arbitrary threshold in summer where they say, okay, now sticking to the actual time would yield Isha times which are very late and Fajr times which are very early. Because of the hardship associated with this, we basically switch to artificial times gradually, right? That's what they do. And yeah, in the context of classical paradigms, this is clearly problematic because it is explicitly stated in all 4 schools that one needs to follow the signs as long as they exist. So you cannot just say that's too hard for me. I will just use artificial times. As I said, if we actually really want to follow classical paradigms, which I think we should do. Then the Fazilat calendar. This is a more traditional calendar. They have the most precise Tamkin calculation among the calendars that I've analyzed. So all of these calendars times for Berlin for 2024 have been compared with my times for the same city and time. And my results are based on that analysis. You can find that analysis in the thesis. So as I've said, the Fazilat calendar has the most precise Tamkin calculation among all of these calendars. They calculate Fajr and Isha at 19 and 17 degrees match. And they do this as long as possible, as long as the actual sign exists. And during summer, they switch. They not really switch, but they calculate Fajr at astronomical midnight, which, as I've explained, is what the 4 schools say. And they calculate Isha according to the Aqrabul Bilad bin Nisba method. But I have to say, I've checked the Aqrabul Bilad bin Nisba time, and I don't really agree with what they think is, so what they have as the result. So I think there are some additional assumptions that they make, which I don't really understand. So the Aqrabul Bilad bin Nisba time, I do not approve of it. Let's put it that way. Then we have the calendar of the Islamic Center in Aachen. This is basically the same calendar as Diyanet and Hijrat. The Hijrat calendar is used by IGMG. I have forgotten to say that if it's relevant for any English-speaking person. So this is the calendar of the Islamic Center in Aachen is basically the same as Diyanet and Hijrat. But the only difference is that they use 5 minutes, a fixed buffer of 5 minutes instead of 7 for Shuruq and Maghrib, and 3 minutes for Asr instead of 4 minutes. And another difference is that they use 17 degrees for Isha instead of 16 degrees. Basically the same criticism that I've just made about Tamkin in case of Diyanet also applies to this calendar. And also the fact that they only in parts of the year calculate according to these parameters. On one hand side the parameters are wrong, on the other hand side they don't even stick to these parameters as long as possible, so quite problematic. And the method they use for their artificial times is basically the same method as the Diyanet calendar uses. However, they have written their own 17 degrees variant of this, of this method, and they are using it. Okay. Then we have two calendars, which are finally two Turkish calendars, which are very similar and also quite traditional, like the Fazilet calendar. Let's start with the Samarkand calendar. The Samarkand calendar calculates Tamkin only partially. The times Isha and Fajr do not have any Tamkin corrections in the Samarkand calendar, which is problematic from my point of view. Fajr is calculated at 19 degrees as long as possible, and Isha is calculated at 17 degrees only in parts of the year. Why? Because during the summer month, the Samarkand calendar does the following. As soon as the sun does not fall to 19 degrees or more, so as soon as the whiteness of twilight begins to persist through the night, they go one day back, look at their Fajr time and Isha time, and they fix these two times for the entire time period in which at least the whiteness, or that's the first that happens, in which the whiteness of twilight persists. So on each and every day on which whiteness persists through the night, they use the last time from the day on which whiteness did not persist for Isha and Fajr. They just fix the time, and you have the same time for more than a month, depending on where you are, right? So this is problematic, because just because whiteness persists through the night, this doesn't mean that redness also persists. And we have seen that the main position concerning Isha, also in the Hanafi school, right? I mean, as long as Isha enters according to the second position of the Imamain, one should clearly still follow it. Isha would still enter, right? Because redness still disappears. So in this sense, they are using an artificial time for Isha, although the time of Isha is still existent. And this is kind of problematic, right? The Turkiye calendar, they calculate Tamkin for each and every time, and the Tamkin calculation is reliable. So if you follow their times, no worries, Tamkin will be given consideration to. But the problem is, it's not really a problem, but it's just, it could be better. It's very coarse. So their Tamkin calculation could be refined. It could be much more detailed, right? It could be much more precise. That's what I'm meaning. The rest of their calendar is basically the same as the Samarkand calendar. So they also use 19 degrees and 17 degrees. And during the summer months, they also fix the last Fajr and Isha time. And given that they given that they calculate Tamkin for Isha and Fajr and Samarkand does not, the times will still be different between both calendars, but they basically use the same principle. Okay. That's it from me. Thank you for your kind attention. I was aiming at 90 minutes, but I see I'm close to 2 hours now. Many apologies, but this is the first time that I give this talk in English. Most probably that's the reason. Before finishing, I would like to show you again the publication. We have really, so we went for the highest production quality. So really, this is a leather hardcover, so enjoyable production, I would assume, I would claim. So if anyone wishes to purchase a copy, you can basically visit the website of the Vakar Publishing House of Vakar Yayınları. And yeah, that's it from me. Hope to see you on another occasion.